Have you ever wondered what happens when the heart of a factory, a massive industrial boiler, suddenly fails? It's not just a breakdown, it can be a catastrophic event. But what truly causes these powerful machines to fail? It's often a story hidden deep within the metal, a tale that only a specific kind of detective can uncover. Today, we're diving into the fascinating world of forensic engineering to expose the unseen culprits behind devastating boiler failures. First, let's be clear. A boiler isn't just a big kettle. It's a complex high-pressure system operating under extreme temperatures. The energy it contains is immense. When that energy is released uncontrollably, the consequences are serious. This is where forensic engineers step in. They aren't just looking at the aftermath, they're reading the story the wreckage tells them. Their job is to sift through twisted metal and fractured components to find the root cause, the single point of failure that started it all. One of the most common but insidious villains is corrosion. It's a silent attacker. Imagine tiny pits forming on the inside of a water tube, slowly eating away at the steel. This could be due to improper water chemistry, where dissolved oxygen or acidic conditions create the perfect environment for rust. Over time, these pits weaken the tube wall. Under the immense pressure of daily operation, what was once a tiny weak spot can suddenly rupture, leading to an explosive release of steam. A forensic engineer will examine the fracture surface under a microscope, identifying the telltale signs of fatigue cracks or the brittle fracture characteristic of corrosion, piecing together the timeline of destruction. Another hidden enemy is overheating. Boilers are designed to have water circulating constantly to keep the metal tubes cool. But what if a blockage occurs? Maybe mineral deposits, what we call scale, build up inside a tube, restricting water flow. The fire is still roaring, but that section of the tube is no longer being cooled effectively. The steel's temperature skyrockets, it loses its strength, and it starts to deform, almost like taffy. Eventually, it can no longer contain the pressure and bursts. Forensic analysis reveals this through telltale signs like a fishmouth rupture, a long, gaping tear in the metal, and a change in the steel's microstructure, visible only at high magnification, confirming it was exposed to temperatures far beyond its design limits. Then there are the manufacturing or repair defects. A tiny, almost invisible crack introduced during the welding process can be a ticking time bomb. For years, it might do nothing, but the constant cycle of heating and cooling, pressurizing and depressurizing causes this tiny flaw to grow, a process called fatigue. It grows slowly, invisibly, until it reaches a critical size. At that point, the failure is instantaneous and total. By analyzing the beach marks on the fracture surface, which look like ripples on sand, an engineer can literally count the cycles that led to the final break, tracing the problem back to its origin. So, why does this matter? By meticulously reconstructing these failures, forensic engineers do more than just solve a puzzle. Their findings lead to improved safety standards, better maintenance procedures, and innovations in material science and boiler design. Each investigation is a crucial lesson that helps prevent future disasters, protecting property, and most importantly, saving lives. The silent stories told by fractured steel become the loud and clear safety warnings for the entire industry. It's a powerful reminder that even in our most advanced systems, the smallest details matter immensely. Thank you so much for joining us on this deep dive into the world of forensic engineering. It's a field where science meets detective work to make our world safer. If you found this fascinating, please hit that like button, subscribe for more content, and ring the bell so you don't miss our next investigation. See you in the next video.